All right, today we're going to talk about operations with functions, section 9.41. We're taking this lesson basically breaking up over 2 days just to make sure we understand it a little bit better. But operations with functions, section 9.4.1. We are going to be doing some evaluating, looking at some functions. If you can combine like terms, if you can multiply, if you can simplify with respect to fractions and dividing, and if you can evaluate functions, you can do everything we're doing today. So here's what it is. You basically follow these steps to perform operations with functions. Step 1 is use the notation rule for the operation. All that means is these are the same thing. And you see both of them. For example, you can see f plus g of x equals f of x plus g of x. You will see the same thing written either way. Some textbooks really use the left side. Some textbooks really use the right side. ACT, they'd use one or the other. They might use both of them. But it's the same type of problem. F plus g of x just really means f of x plus g of x. Now, what's that mean here? Well, at the top, it says f of x equals x squared minus 9. G of x equals x minus 3. So when I go to simplify this, I take f of x, and I add g of x. And I'm just going to combine like terms. And I get x squared plus x minus 12. Okay, it's nothing more than combining like terms. Same thing for subtraction. F minus g of x is the same thing as f of x minus g of x. So I take f of x minus g of x, combine like terms, and I get x squared minus x minus 6. Okay. Again, all this is you're substituting. What does f of x mean? Plug it in. What does g of x mean? Plug it in. And either add, subtract, multiply, or divide to simplify the expressions. Multiply, same thing here. Fg of x just means f of x times g of x. So I take f of x, I take g of x. If I have two sets of binomials or two sets of parentheses like that, what expression do we call that when we have to multiply? We call it FOIL, first outer and last. So if you have two binomials like that, you do have to FOIL and then simplify, and you get an answer that looks something like that. What?
I prefer saran wrap.
And then divide. Now divide is one step a little bit harder. So if I have f over g of x, which is really f of x over g of x, I write it as a fraction. Now whenever I have a fraction with respect to variables, I can simplify. So notice they took x squared minus 9 and simplified it down to x minus 3x plus 3. What did they do next? They canceled the x minus 3's out. Why'd they cancel them? Because we could simplify. And then when we simplify, you get x plus 3, and x cannot equal 3. Do you remember why x cannot equal 3? Because what cannot be 0? Yeah, that 3 right there comes from the denominator. Okay, comes from the denominator there. X minus 3. 3 cannot, or x cannot equal 3 because you can't get 0 in the denominator. All right, great. So let's look at these problems. Use the following functions for all problems. Now in these functions, I know that f of x equals x, g of x is x minus 3, h of x is x squared minus 9, and k of x is 2x. So I have 4 different functions that I'm going to use to evaluate these. All right? So first thing here, I have g, k of x. So when they're like that, that really just means g of x times k of x. Okay, that's the same function. Why plug in g of x? G of x is 3x. K of x is 2x. And now I need to multiply them. Well, to multiply them, I'm just going to distribute. 2x times x is 2x squared. 2x times negative 3 is negative 6x. Well, guess what? That's my answer right there. So all you're going to do is plug in what the functions are and then simplify with the operation. So is it add, subtract, multiply, divide, and perform the operation, and you're done. Next one, number 2. I have g plus k of x, which is the same thing as g of x plus k of x. What's g of x here, Andy? So I get x minus 3 plus, what's k of x, Maddie? 2x. And I'm adding them so I combine like terms. What's x plus 2x? Nothing to combine with negative 3, so I get 3x minus 3. Number 3, k minus f of x. What's another way that that could be written? How else would that be written, Jack?
Another way.
Like, instead of k minus f all of x, like this one, we went here. We broke it down to the two different functions. So what's the other way it could be written? Correct. But really, I want to go one step before that. So it's like k of x minus f of x. I want you to see that they're the same thing. That's all I wanted. Okay. So see they're the same thing here. And yeah, it's just like kind of distributing the x to both of them. Like k of x, f of x, you know. So what's k of x here? K of x is, as John said, 2x. F of x is 2x minus x is x. There's your answer. Again, if you can add, subtract, combine like terms, multiply, divide, you can do everything we're doing today. Number 4, k over f of x. And that would be the same thing written as kx over f of x. Now what is kx here? Kx is f of x is k. So 2x over x. How does that simplify with respect to division? What happens to x is I have an x up top and x on the bottom. They would then cancel. So I'm left with 2. I'm left with just 2 because 2 over 1, which is just 2. Does everybody understand that? Okay. And now, so I have 2. I'm going to put a colon here, or semicolon. X cannot equal what value? 0. X cannot equal 0. So I get 2 and x cannot equal. Why can x not equal 0? Because I just have x in the denominator, and my denominator can never be 0. So x cannot equal 0 here. If it were like x plus 2, then I have x cannot equal negative 2 or something like that. But because it's just x, it cannot equal 0. Okay, let's try number 5. hk of x. Again, that'd be like saying h of x times k of x. Well, what's h of x here? X squared minus 9. What's k of x? 2x. I'm going to multiply those and simplify. When I multiply them, what do I get? Basically, I'm just trying to distribute. Jack, what do you think?
2x cubed minus 18x.
2x cubed minus 18x. Nice job, sir. All right, what about number 6? H over g, all of x. Again, I can rewrite that as h of x over g of x. What's h of x here, Andy? What's g of x here, Maddie? Awesome. So I have x squared minus 9 over x minus 3. Can I simplify the numerator here? How does that simplify? Yeah. So I get x plus 3 and x minus 3 all over x minus 3. What cancels out? So I'm left with x plus 3. And what can x not equal? X cannot equal 3. Nice job. Take a couple seconds to try the last 3. Try number 7, 8, and 9 with respect to simplification. Number 7. H plus f of x is really just h of x plus f of x. What did you get for that one, Andy?
X squared plus x plus 9.
X squared plus x minus 9. Nice job. Number 8. G minus k of x. So which is really g of x minus k of x. What do you get when you get g of x minus k of x, Jack? Almost. You forgot one detail there. Negative x minus 3. Because you get x minus 3 minus 2x. So x minus 2x is negative x minus 3. And then number 9. G plus h of x, which is really just g of x plus h of x. When I combine like terms there, what do I get, Maddie?
X squared minus 6. Oh, just kidding. I forgot to.
John? x squared plus x minus 12. Because when you add subtract, you can't combine different exponents. That's where you're at. And there you go. Next part here. So that's kind of function operations here. Add, subtract, multiply, divide. Nothing too bad. Next part here. This is one of the best things I love to do. Operations of functions. This is called composition of functions. You can use the following functions for all problems. Again, we have the same functions here. We have x, x minus 3, x squared minus 9, and 2x with respect to f of x, g of x, h of x, and k of x. Now, I like to call these problems just kind of similar to you work inside out. Now, why do I say you work inside out? Because all the parentheses, does everybody see all the parentheses there? It's like taking the problem from the inside out to work it. It's just order of operations because you go parentheses, then the next parentheses, that type of thing. But it's just similar or simpler to say go inside out on these. What happens here is I evaluate once, I get an answer, and then I evaluate again. So for instance here, I have g of h of 10. Well, what happens here is I'm going to take this 10 and I plug it into my h function. So I take the 10, I plug it into my h function, which they kind of did below there. 10 squared is 100. 100 minus 9 gets me 91. So what happens here is then I get 91. I then take that answer and I plug it into my next function. So I get g of 91. So I take 91 and plug it into my g function. What's 91 minus 3? 88. The answer to number 10 is 88. Okay, what happens here is you're going to input a function. You're going to get an output. Take that output, input it into the next function, and get an output again. Okay, again, functions are like input-output. Like, remember, I think we talked about it way back when. It was like a vending machine. You input a dollar, you output whatever you press. Okay, input-output functions. So yeah, kind of like a multiple step thing. Yep. So number 11 here. Let's try this one. I'm going to take negative 1. Which function do I need to plug negative 1 into? F. I go inside out. So I'm going to plug it into F. Well, f of x is just x, so what do I get out? If I plug negative 1 in, I get negative 1 out. So then I'm going to do g of negative 1. Because if I already just did f, now I'm going to do g. So I take negative 1, I plug it into g. What's negative 1 minus 3? Negative 4. And there's my answer. Input, get an output, take that output, put in the next input. So number 12, f of g of 2. I'm going to take 2 and I'm going to plug it into which function first? G. So take 2, plug it into G function. 2 minus 3 gets me negative 1. So I now have f of negative 1. Take negative 1, plug it into what function? And I get
negative 1.
There's my answer. Try number 13. G of k of 3. I'm going to take 3 and I'm going to plug it into which function first? K. Now I get 6. So I get g of 6 now. Take 6, plug it into my g function. 6 minus 3 is 3. Let's try 14. H of g of 3. Take 3, plug it into which function first? G. 3 minus 3 is? I get h of 0. Plug 0 in for x, and I get negative 9, because 0 squared is 0, minus 9 is negative 9. Number 15, plug negative 3 in for? Okay. 2 times negative 3 gets me? Now I have h of negative 6.
No, 36 minus
27. Negative 6 squared is 36. 36 minus 9 is 27. Try number 16, 17, 18 on your own. Number 16 is? Negative 4. Because I get f of negative 2, which is negative 2, so I get k of negative 2, which is negative 4. 17. K of g of 0 gets me negative 6. Because g of 0 gets me to negative 3. K of negative 3 gets me to negative 6. And number 18, I get negative 16. Because h of 1 gets me to negative 8. K of negative 8 gets me to negative 16. Composition of functions right there. Feeling pretty good? Great. These are just other ones very similar to that. You just have to add, subtract, multiply, divide. Nothing too bad. Here's your assignment.